Good morning, dear students and all the viewers. It's me, Indra Madigewali, math teacher for grade 9. Welcome you all in today's session. So today we will learn about simplification of rational expressions. So first of all, on the topic of simplification of rational expression, so let me talk about what are rational expressions. Then we will practice questions based on simplification. So what are rational expressions? We can see on the slide, so I have mentioned there. In fact, rational expressions are those expressions which can be written in the ratio of two polynomials. For example, so x plus y over x minus y, this is a rational expression where the very important point is the denominator of the fraction cannot be 0. 2y over x. We can take lots of examples of rational expressions. So x plus y over x minus y, where x minus y should not be 0. Similarly, in the next example here, 2y over x, x cannot be 0 if this is a rational expression. What if the denominator is 0? Obviously, if the denominator is 0, so 2y over 0, if the denominator of the fraction is 0, then its result will be undefined. So 2y over 0 gives undefinite value. So we do not make denominator 0 in rational expressions. So after getting the concept of what are rational expressions, now we can practice questions based on simplification of rational expressions. Let me repeat this again. Rational expressions are the expressions which can be written in terms of two polynomials. Here the polynomials can be monomial, binomial, or trinomial, and so on. But there must be numerator and denominator. It's a fraction, and denominator of the fraction cannot be 0. Now let me take a first question. We can see on the slide. First question is a square plus 3a plus 2 over a square plus a minus 6 times a square minus 9 over a square minus a minus 6. So we are simplifying this rational expression. So what should we do in the very beginning? Let me explain about the few steps in simplification. First of all, we need to find the factors of numerator and denominators, all the polynomials of numerator and denominators. Then after factorizing numerator and denominator, then in the second step we cancel the common factors, and in the third step we write in lowest term. So first step, factorization of numerator and denominator. Second step, we cancel common factors from numerator and denominator because there is multiplication, so we can cancel this. And in the third step, we simplify by writing into lowest term. So let's begin this. First expression here is a square plus 3a plus 2. This is trinomial expression. There are three terms, so we need to factorize this. A square plus 3a plus 2. We know how to factorize this. We split the middle term like a square plus 2 plus 1a plus 2 over While factorizing such expressions, we split the middle term, and before that we need to know what is the product of two numbers and sum or difference. So here coefficient of a square is 1 and constant term is 2. So what is product of 2 and 1? 2, and sign of 2 is plus positive, so sum is coefficient of a 3. So what are two numbers whose product is 2 and sum is 3? So these two numbers are 2 and 1. What is 2 times of 1? 2. And what is 2 plus 1? 3. Similarly, now we can factorize the denominator a square plus a minus 6. So product of two numbers should be 6, and difference of these numbers should be coefficient of a 1. So what are two numbers whose product is 6 and difference is 1? These two numbers are 3 and 2, which are the factors of 6. So a is square plus 3 minus 2 times a minus 6 times, we can see here a square minus 9. We can easily factorize converting this into a square minus b square form. So a whole square minus 9 is 3 whole square over, again we need to factorize a square minus a minus 6. So a is square minus 3 minus 2 times a minus 6. Now let's factorize a is square plus 2a plus a plus 2 over a square plus 3a plus minus is minus 2a minus 6 times, what are the factors of a square minus b square form? We have two factors, a plus b. So a plus 3 is one factor and a minus 3 is other factor, over a is square minus 3a minus 3 times a is minus 3a, so minus minus plus 2a minus 6. Now we can take common from first two terms here, a square plus 2a, and then from a plus 2. So what is common from a square and 2a? A is common. So a plus 2 plus what is common from a and 2? There is no common factor, so 1 is always common. So 1 is common, a plus 2 over, let's take common from a square plus 3a. So a is common, a plus 3 minus from 2a and 6 minus 2 is common, a plus 3 times, we can write these two factors as it is, a plus 3 times a minus 3 over, let's take common from the pair of terms, a is common, a minus 3 plus 2 common, a minus 3. So this is equal to, if we look at this here, a plus 2 is again common factor, so we can take a plus 2 common, a plus 2 times what is the remaining factor, a plus 1 over, in the denominator a plus 3 is common, a plus 3 times a minus 2, a minus 2 multiply by a plus 3 and a minus 3. So these two are the factors, a plus 3 times a minus 3 over, what is common factor here in the denominator, a minus 3 is common, a minus 3 times remaining factor is a plus 2, a plus 2. So in the first step of simplification, we factorize numerator and then denominator, and now in the second step we can cancel the common factors. a plus 3 is one of the common factor. Again a minus 3 is common factor. We also can see a plus 2 is common. So we cancel out the common factors from numerator and the denominator. Now what are the factors left? So factor in the numerator is a plus 1 over denominator a minus 2. So this is the final answer in lowest term. So let me recall this. This is a simple simplification of rational expression where we factorized numerator a square plus 3a plus 2 times a square minus 9, and then the denominators a square plus a minus 6 and a square minus a minus 6. We factorized them and then we cancel here the common factors and we simply have written here remaining factors. So this is the final answer in simplest form. Now similarly, let me take number 2, question number 2 for simplification. Number 2 is a square over a minus b plus b square over b minus a. So this is next question for simplification. What is the first term? A square over a minus b, and second is plus b square over b minus a. In case of simplification, having like terms in the denominators, if the denominators are like, we simply add or subtract the numerators and then we write in simplest form. We can see here the denominator in the first term is a minus b and the denominator in the second term is b minus a. Here I am supposing this is the first term and this is second term. Let's think, can we convert b minus a into a minus b and make like denominator? Let's see here, b minus a is equal to, if we take negative sign common, sign of these two terms will be changed. So what is the sign of b? It's plus here. Now after taking negative sign common, we need to change sign. It becomes minus b, and sign of a is negative. We have taken negative sign common, so sign should be changed. So it will be plus a. So negative sign a minus b. So b minus a is equal to negative sign times a minus b. So let's write same thing here. A square over a minus b plus b square over b minus a square over a minus b. What is b minus a? So b minus a is negative sign times a minus b, so plus b square over negative sign times a minus b. So this is equal to a square over a minus b. What is plus minus? Minus b square over a minus b. Here denominators are like a minus b, so simply we need to subtract numerators. Now let's take LCM is a minus b. This is common denominator, so this is equal to LCM of denominator is a minus b. So a minus b is common denominator, so simply we subtract now numerators. A square minus b square. We can say in the numerator there is a square minus b square. We can factorize this to a plus b and a minus b. These are the two factors of a square minus b square over a minus b. Now we can cancel the common factor from numerator and denominator, which is a minus b, and we obtain the result a plus b. So this is the way we factorize and simplify the rational expressions. In case if the denominators are unlike, what should we do in that case? In case of simply like denominators, we add or subtract numerators depending on the sign. Sign is negative here, so simply we subtracted this and we factorized a square minus b square to its factors a plus b, a minus b. If the denominators are unlike, like a minus b, a plus b, or like that, in that case we need to take LCM of the denominators, and each denominators, or after taking LCM we divide LCM by each denominators, and the result will be multiplied in the numerator of corresponding terms, corresponding denominators. So let's practice now. Next question, number 3. Next question here is x is square minus a square over ax plus a square times 7a over x minus a. So first of all, we need to factorize numerator and denominator in the first step of the simplification. We need to follow few steps in such short questions. First we factorize numerator and denominator, then we cancel the common factors, and then we write in lowest terms. So can we factorize x is square minus a square? This is in a square minus b square form, where a is x and b is a. We can factorize to ax plus a times x minus a over what is the common letter here in ax plus a square. A is common, so x plus a times 7a over x minus a. Now we can cancel the common factors. X minus a is common, x plus a is also common, and we also have common factor a. We cancelled all the common factors. Now what is the term left here? We have 7 left. So this is the final simplest form of this simplification. Now let's practice some other questions of simplification. We have the next question here, a square plus ab plus b square over a plus b plus a square minus ab plus b square over a minus b. Let's see the denominators. If the denominators are unlike, we need to take LCM. Let me rewrite this: a square plus ab plus b square over a plus b plus a square minus ab plus b square over a minus b. What are the denominators? A plus b, a minus b. So these two are different. In this case, we take LCM of the denominator. So what is the LCM here? LCM is a plus b and a minus b. These two are different. That's why we need to take both. There is no common factor. Now what should we do after taking the LCM of denominators? Now a plus b times a minus b is LCM. In simplification, after taking LCM, okay, we divide this LCM by denominator of each term. So this is first term and this one is second term. Now we need to divide LCM a plus b, a minus b by, okay, a plus b is the first denominator. So I am dividing this LCM by a plus b, then the result is multiplied to its corresponding numerator. So let me write numerator as it is, a is square plus ab plus b square times. Now when we divide LCM a plus b times a minus b by the denominator a plus b and a plus b, these two are cancelled out. So what is the factor left? A minus b. So we need to multiply by a minus b in the numerator of this corresponding denominator plus in the second term, let's write this same, a is square minus ab plus b square, okay, times. Now let's divide LCM a plus b times a minus b by a minus b. Two common factors, a minus b will be cancelled out and the remaining factor is a plus b, and this is multiplied in the corresponding numerator here. So a plus b. Okay, now if we say this one, a minus b times a square plus ab plus b square. If we try to recall the formula or the factors of a cube minus b cube and a cube plus b cubes, let me write here. A cube plus b cube factors are a plus b times a square minus ab plus b square. A cube minus b cube, its factor a minus b times a square plus ab plus b square. Let's see the factors of, okay, two formulas, a cube plus b cube and a cube minus b cube. This one, a minus b times a square plus ab plus b square, okay, these two are the factors of a cube minus b cube, or we can simply multiply, okay, a minus b and a square plus ab plus b square to obtain this result. Here I am writing, okay, directly the form a cube minus b cube, because a minus b times a square plus ab plus b square, these two are the factors of a cube minus b cube, we know this. So a cube minus b cube plus a plus b times a square minus ab plus b square. So these two are the factors of, again, a cube plus b cube. So we can write a cube plus b cube over a plus b times a minus b. This is the LCM, and same. We can see negative b cube and positive b cube. We can cancel this negative and positive. We have like terms, okay, a cube, so this is 2a cube over a plus b, a minus b is a square minus b square. We can combine a plus b times a minus b and write a square minus b square. So this is the simplest form of this expression. Now we can take some other questions for practice. Let me write here. Next number, we are practicing simplification of rational expressions. Let me write here. Next question, 1 over a minus b whole square minus 1 over a square minus b square. Okay, let's see in the first term we have the denominator a minus b whole square, and in the second term we have the denominator a square minus b square. 1 over a minus b whole square minus 1 over a square minus b square. So the first denominator here is a minus b whole square. So what are the factors? What are the factors of a minus b whole square? We know it has two factors, a minus b times a minus b minus 1 over what are the factors of a square minus b square? We can factorize a plus b times a minus b. After this, we need to take LCM of the denominators. So while taking LCM of the denominator, first of all, what is LCM? LCM is common factors times remaining factors from both denominator. So let's take LCM of denominators. First of all, what is the common factor here? A minus b is one of the common factor. A minus b is common factor from first denominator and second denominator. Now, is there any common factor left? A minus b, there is no factor a minus b in the second denominator, and a plus b is only in the denominator of second term. So only a minus b. So this is the common factor, a minus b. Now we need to write the remaining factors. This a minus b is one of the remaining factor times a plus b is here, a plus b. Now it's same like the previous questions. After taking the LCM of denominator, we divide LCM by denominator, then we multiply the result in corresponding numerator. So here if we divide LCM a minus b times a minus b times a plus b by first denominator a minus b times a minus b, so two factors a minus b will be cancelled out, a minus b and a minus b will be cancelled out, and what is the factor left? A plus b. So 1 times a plus b minus 1 as it is times, when we divide this LCM by denominator, a plus b times a minus b, when a plus b is this a plus b is cancelled, a minus b is also cancelled, we have only a minus b left. Now we can open the bracket in numerator. So 1 times a plus b is same a plus b minus a, minus is plus b over a minus b times a minus b and a plus b. So we can cancel a, negative and positive a. What is the sum of b plus b and b? This is 2b twice of b over, now we can combine these factors from the denominator. So a minus b times a minus b is a minus b whole square times a plus b. This is the simplest form. So that's all for today. Thank you everyone for being with me, and have a wonderful day ahead. Thank you.